we're discussing the acceptable insulation resistance value for a healthy electrical cable rated at 600/1000 volts, referencing the National Electrical Code, or NEC. The NEC doesn't explicitly state a specific acceptable insulation resistance value for a 600/1000 volt cable. However, the NEC does provide a general guideline. It recommends a minimum insulation resistance of 1 megohm for each 1000 volts of rated voltage. Applying this guideline to a 600/1000 volt cable, the minimum acceptable insulation resistance value would be 2 megohms. This calculation is based on the 2 lots of 1000 volts of voltage rating. It's crucial to understand that the insulation resistance of a cable isn't a fixed value. It can vary significantly based on several factors. One important factor is the length of the cable. Longer cables typically exhibit lower insulation resistance values because there is more surface area and volume of insulation exposed to potential leakage paths. Another factor is the cross-sectional area of the conductor. Cables with larger conductors may have different insulation characteristics compared to those with smaller conductors. Temperature plays a significant role. High temperatures generally reduce insulation resistance as the insulation material becomes more conductive. Moisture content is also a key factor. Moisture ingress into the cable insulation drastically reduces insulation resistance, creating a potential path for current leakage and increasing the risk of electrical faults. Given these variables, it is strongly recommended to consult the cable manufacturer's specifications for the specific cable being used. These specifications provide detailed information about the cable's insulation properties, including the expected insulation resistance value under specific conditions. Relying on the manufacturer's data ensures accurate assessment of the cable's health and prevents misinterpretation of insulation resistance measurements. Furthermore, regularly testing and monitoring insulation resistance is essential for maintaining electrical safety and preventing equipment failure. The insulation resistance test, often performed using a megameter, also known as a megar, applies a high voltage direct current, or DC, across the insulation to measure the leakage current. A low leakage current indicates high insulation resistance and good insulation quality, while a high leakage current indicates lower insulation resistance and potential insulation degradation. When interpreting insulation resistance readings, it's important to consider the environmental conditions at the time of testing, such as temperature and humidity. Also, any previous maintenance or repair work on the cable that could affect its insulation. A trending analysis of insulation resistance measurements over time can provide valuable insights into the cable's condition and help detect early signs of insulation degradation. This allows for proactive maintenance and prevents unexpected failures. In summary, while the NEC provides a general guideline of 1 megohm per 1000 volts, the actual acceptable insulation resistance value for a 600/1000 volt cable depends on various factors, and the manufacturer's specification should always be consulted for the most accurate assessment. Regular testing and monitoring are crucial for maintaining electrical safety and preventing equipment failure.